Hey everybody, welcome back to Welch's math class. It is so good to see you. We're going to talk a little bit more algebra today. That's what we got. Are you ready? Let's get to it. Today, this time, we're going to talk about section 9.5. I know we talked about it some before. We talked about what an algebraic expression is. We talked about the difference between an expression and an equation. We also talked about how to evaluate an expression given some values. But today, this time, we're going to spend a little bit of time talking about how to simplify algebraic expressions. It's very important that we know a couple of ways that we can take more complex algebraic expressions and simplify those down to simpler, easier, smaller expressions. So the first thing I want to talk to you about is something called like terms. Like terms. Like terms, we need an S on that. Like terms, these are algebraic terms. Algebraic terms that have the same variable raised to the same power. Okay? So like terms, these are algebraic terms that have the same variable raised to the same power. That's what we're looking at right there with like terms. Notice that I didn't say they have the same coefficient. They don't necessarily have the same coefficient. So let me give you some examples of like terms, and that'll help you a little bit, maybe to kind of get hold of what I'm going after here. Again, catch this in your notes. Algebraic terms, terms that have the same variable raised to the same power. Okay, let's lose that, and let's give you some examples of what I mean by like terms. 5x and 7x, those are like terms. They both have x to the first power, x to the first power. Notice the coefficients are different from one another, but the variables are the same. 3x squared y to the third and negative 5x squared y to the third. Those would be like terms because they both have an x to the second power and a y to the third power, each one. Coefficients are different. Okay? Now, in this course, we won't be working really with anything that has multiple variables in the same little expression. Mostly will just be one variable to the first power with what we're going to be doing. But I wanted you to see this. This is just another example of like terms. Not like terms. An example of a not like term might be something like 7x y and 7x squared y. Now these are not like terms, guys. I want you to see that. They have the same coefficient, but that doesn't matter at all anyway. Like terms never have to have the same coefficient. They do have the same variables, an x in each one and a y in each one, but in this one the x is raised to the second power, and this one it's only to the first power. Those are not like terms. So I wonder if you might be wondering now, why is he making such a big deal about like terms? What's the big deal about like terms? So what? Well, there is a so what to like terms. What I want to tell you here, I want you to get hold of this, is that let's try that again. We can simplify algebraic expressions by combining, that is adding or subtracting, combining the coefficients of like terms. We can simplify algebraic expressions by combining the coefficients of like terms. Let me give you some examples of what I'm talking about. We might have 5x plus 3 plus 4x. Well, that'll simplify by taking the 5x and the 4x, which are like terms, combining those, the 5x and the 4x, to get me a 9x plus 3. So we can simplify this expression by combining the like terms, 5x and 4x, okay, and ending up right here. All right, let's give you another example where we do this. If we have, let's say, 3x minus 5y, let's go minus 2x plus y, and let's say we've got this is a 4-term expression. You see, 3x is a term, negative 5y is a term, negative 2x is a term, and plus y is a term. All right, so if we take these and combine the like terms, the 3x, I'll circle that, and the negative 2x are like terms. They can combine to be a 3x minus a 2x, gives me a 1x. Now 1x, I don't have to write the coefficient 1 in front of it. If it's just a 1x, I can just call it x, because x is how many x's? Well, it's 1x. All right, and then I take the negative 5y, I'm going to put a rectangle around that, and I'm going to put that with the positive y. So a negative 5 and a positive 1 coefficient is going to be a negative 4y. So what we see here, when we combine these like terms, we got to recognize our like terms first, but then when we put our like terms together by combining their coefficients, we can take this 4-term expression and bring it down to a 2-term expression. We like to simplify algebraic expressions as much as we can. Very important in being able to work with these expressions, that we'd be able to simplify them. So one way we can simplify algebraic expressions is by looking for the like terms and combining those. Okay? There's another way we can simplify algebraic expressions you need to know about also. Very important way. So let's take a quick look at that. All right. So this time we're going to talk about simplifying an expression by distributing. D-I-S-T-R-I-B-U-T-I-N-G. We're going to talk about simplifying an algebraic expression by distributing. Now, it's probably best if I give you an example of this. That's going to be the easiest way for you to see it. Let's start off very simple. Let's start off with 4 and then a parentheses, and let's throw an expression in here like 2x minus 3. So this is an algebraic expression, okay? And so we want to simplify this. Well, what we're going to look at is this 4 will distribute through the parentheses. This parenthesis means times, so it'll be 4 times both terms in the parentheses. So first we'll go 4 times 2x, okay? 4 times 2x, and that'll give us 8x. And then we'll do the 4 times the negative 3, and that'll get us a negative 12. So the expression 4 parenthesis 2x minus 3 simplifies down to 8x minus 12. 8x minus 12. So another way to simplify an expression. Let's put another one up here as an example for you. Okay. Let's take a look at negative 6 times 5b minus C. 5b minus C. All right, so we've got this expression in the parentheses. We've got the negative 6 out front. We're going to distribute the negative 6 through here. Again, that means we're going to take the negative 6, multiply it first times the positive 5b. A negative 6 times a positive, even though it's not written plus there, we know that's a positive. Negative 6 times a positive 5b. Negative times positive is negative 30b. Negative 30b. That's my first piece here. My second piece is to take the negative 6 and multiply that now times not just c, but times negative c. So this negative 6 times that negative c, a negative times a negative, gets us a positive 6c. So negative 6 distributed through this parenthesis, 5b minus c ends up being negative 30b plus 6c. That's what we end up with in simplifying that expression. So we've talked about 2 ways to simplify expressions. Now let's put them together. The 2 ways that we talked about, remember, were to simplify expressions by combining like terms and then also by distributing. So let's take a look at this longer expression and see how all that fits together. Let's say we have negative 7 times 2x plus 4. And then we come behind that with positive 3 times 4x minus 1. Okay? So fairly complex expression here we want to simplify. Well, the first thing we're always noticing in any math problem is this parenthesis business. All right? So we want to do our distributive property through this parenthesis right here. And so right here, what do we get? What do you guys, I wonder if you know what we get. If you want to pause the video for a second, you're distributing this right here. Okay? Pause, do that. All right, are you back? Great. So in this first one right here, negative 7 times 2x is negative, I hope you got 14x. Negative 7 times positive 4 is a negative 28. Okay? So that's distributing the negative 7 through here. Now, we're going to distribute the positive 3 through this second parenthesis right here. A positive 3 multiplied through here. Pause the video for a second and distribute that yourself and see what you get coming in behind here. Hey, you're back, and let's do that. Let's take a quick look. So what we've got right now is positive 3 times positive 4x is going to be a positive, what's 3 times 4? Oh, I know, 12. 12x. And then a positive 3 times a negative 1 is a negative 3. Okay, so we use the distributive property in this expression twice up here, and we were able to get rid of our parentheses. Now our next step is going to use like terms. We've got some like terms here we're going to go ahead and combine together. These x's, for example, are the like terms. So if I circle up the negative 14x and I circle up the positive 12x, a negative 14 and a positive 12, I hope you know, what do you think that gets you? Did you get it? Maybe, how about negative 2? Negative 2x, okay, when I put those like terms together. Now, let's put the negative 28, we'll do this here, and this here, the negative 28 and the negative 3 together, all right? Negative 28 negatives and 3 more negatives, that gets me all together 31 negatives, okay? So this expression that we started with ends up as negative 2x minus 31. And another example of simplifying. So 2 ways to simplify. One, again, was to combine like terms. The other was to distribute through parentheses. And then we can even put those 2 things together. Now what we'll do from here is we'll take this whole idea of simplifying expressions, which is really heavy-duty stuff in 9.5, although actually the problems you find in 9.5 are probably pretty easy when you get down to it. But you'll be simplifying expressions a good bit in 9.5, and then this is going to be the first step that we're going to use in solving equations when we move forward and some of the things we're about to do after this. So you guys enjoy working out the rest of 9.5. I'll see you on the flip side in 9.6. See you then.